All right, the first type of radioactive decay that we're going to talk about is alpha decay. Alpha decay is usually seen in elements that are closer to the bottom of the periodic table. These elements are generally very heavy. They also tend to have nuclei that are fairly unstable because of the mass of the nucleus. And so the process of nuclear decay, as we have talked about it, is always about going from unstable parent isotopes to more stable daughter isotopes. In the case of uranium 238, our parent isotope, we have a massive nucleus that contains 92 protons and 146 neutrons, and that is an unstable isotope due to the mass of that nucleus. The process of alpha decay is one in which the nucleus itself ejects a small chunk of the nucleus in the form of what's called an alpha particle. Sometimes you'll see that alpha particle written by the symbol alpha, which looks kind of like this, with a 2 and 4 atomic number and mass number together. What that is, though, is what we refer to as a helium nucleus. The alpha particle is a helium nucleus that is essentially being ejected from this unstable parent isotope. What's left is always a daughter isotope that is more stable than the parent that it came from and will always differ from the parent isotope in two very predictable ways. The atomic number will be 2 less than the atomic number of the parent isotope. In this case, we go from 92 to 90, and therefore we've produced a new element in the process. This is the element thorium. The mass number will also decrease, but it will decrease by a total of 4 because a nucleus of helium is 2 protons and 2 neutrons. So we're losing 4 what we would call nucleons, and so our mass number has to decrease by 4. Let's do one as practice. Let's say I have the element polonium. Polonium comes in many different isotopes, but it has 84 protons always, and we're going to go with the isotope of polonium 210. And this is going to serve as our parent isotope. And we want to think about what happens during the process of alpha decay for polonium 210. Well, we know that we're going to get an alpha particle, so we're going to write that as a helium nucleus, just like that. And what we have to do is make sure that we remain balanced on the right side with the left side in terms of our total number of nucleons. So for instance, in this case, we're going from 84 to 2 and 82 because 82 plus 2 is 84. On the left side, we're going from 210 to 4 and 206. So what I have to do is I need to go and I need to look up on the periodic table which element has 82 protons. That happens to be lead. And so in this particular case, we're producing a more stable daughter isotope by releasing a helium nucleus, an alpha particle, and producing the more stable lead-206 isotope. Okay, we'll look at another form of radiation in our next video.